Welcome back. Today we are working in Algebra 1. The topic is J.8, find the number of solutions to a linear equation. The code is KBP. So in this topic, we are going to be determining how many solutions an equation has. So we've got three different options. There's no solution, one solution, and infinitely many. So in this case, when we are solving these equations, you want to look and see when we solve, do we get a variable equaling a number, like, for example, x equals 5? If so, that means that there's one solution, x equals 5. If you are solving and your variable is eliminated, that means it's either going to be no solution or infinitely many solutions. And it just depends on what you're left with. So if your variable disappears and you're left with a true statement like 0 equals 0, -4 equals -4, or any number equaling itself, that means there's infinitely many solutions, meaning any number that we put in for that variable will work as a solution. But let's say that when you solve, your variable disappears and you're left with an untrue statement like 0 equals 5 or -2 equals +2. In that case, that means that no matter what number we use for the variable, it will not work. So that would be an example of no solution. Let's try this out so you can see what I mean. In this first problem, we've got 0 equals 9q minus 9q. Well, when we solve 9q minus 9q itself minus itself, that means it's just going to be 0. So we get something that says 0 equals 0. Because it says 0 equals 0, that means that it is a true statement. Our variable is gone, so that means that it's going to be infinitely many solutions for this problem. So let's go here and we're going to choose the box saying infinitely many solutions. Click on that. There we go. Okay. In this problem, we've got to solve for W. So there's a little bit more work than the last problem. We've got 5 plus 4W equals 3W. I'm going to start by combining my variables. So I'm going to bring my variables to the right side, which means I'm going to subtract 4W from both sides. That will leave me with 5 equals -W, which when I divide by -1, I get W equals -5. That is one specific solution, which means I'm going to choose one solution. This next one says R minus R equals 0. Well, if I have one R and I take an R away, I get 0, right? I don't have any R's left. So this would leave me with 0 equals 0, which means infinitely many solutions would be our answer. That is a true statement with no variable in it. For this one, I'm going to solve for B, which means I have on one side 5B equals 8 plus 3B. I want to get the b's by themselves, so I'm going to subtract 3b from both sides, leaving me with 2b equals 8. And when I divide both sides by 2, I get b equals 4, which is one specific statement, so that is one solution. In this next problem, looking at it, we've got 9d minus 4 equals -4 plus 9d. So one thing that might be helpful is rearranging it. So notice how the variable is first on the left, 9d minus 4. Let's do that on the right-hand side. So on the right-hand side, I'm going to move my variable first, which is a positive 9d, and I'm going to move my number second, which is a -4. It's a -4. When you rearrange it, you'll notice what you see on the left side, you see on the right side. So the left and right side are exactly the same. If I were to subtract on both sides, I subtract 9d on both sides, they would cancel. And if I added 4 on both sides, they would cancel, and I'd end up with 0 equals 0. This is an example of something that says that it's infinitely many solutions. This problem is asking, is this equation an identity? And when we talk about an identity, we're saying, is the left side the same as the right side? In this case, 0 equals 0, or if you go back to the original one, 9d minus 4 is equal to 9d minus 4. So yes, this is an identity. Let's clear this and go to the next one. How many solutions does it have? So this one is not going to be infinitely many solutions because the left is different from the right. But notice if I write 3g minus 3 equals 3g. I would subtract 3g from both sides to combine them, and they would both cancel out, leaving me with -3 on one side and 0 on the other side. They do not equal each other, so this would be an example of no solution. Let me clear this and we're going to move on to the next one. So in this problem, it says how many solutions does this equation have? We've got -5t on the left, and on the right-hand side, it says -9t plus 4t. The left side has nothing to simplify, but on the right side, if I combine -9 and 4, that gives me -5t. And you'll notice that -5t is the same as -5t, so this is infinitely many solutions. Okay. On to the next one. Is this an identity? Meaning, do we see the same thing on the left side as we see on the right side? So when I go to solve this, I have -10 minus 8t. And on the right side, I have 8 minus 8t. Right away, we can see it's not going to be the same because there's different constants on both sides. The variable is exactly the same. So if we were to add t to both add 8t to both sides, they would cancel. But then we've got a -10 and we've got is equal to a +8, which is not true. This is not an identity, so I'm going to press no. This next problem, I'm going to go ahead and simplify. So I've got -2s plus 3 plus s equals -4s minus 9. So over here, I have -2 s's. And if I add another s to it, -2, I borrowed $2 and I paid someone back $1, it would still be a -1s or just -s. And then plus 3, I can't add those together because one has a variable, one doesn't. And on the other side, I have -4s minus 9. So we are going to have a solution because when I go to combine my s's, I'll add 4s to both sides. And I get 3s plus 3 equals -9. I subtract 3 from both sides and get 3s equals -12. And when I divide 3 on both sides, I get s equals -4. That means that there is one specific solution. In the next one, I see I have -9 minus 10u, and I have it equal to -9u. You can solve the problem like I just did in the previous problem, or because we don't necessarily need to know what the solution is, we just need to know how many solutions, you don't even have to solve it. Look at your variables. You'll notice if we go to combine the variables, if I were to add 10u to both sides, that's going to give me a u still. My variable doesn't cancel out. So if looking at these equations, you notice that your variable will not cancel out, that it'll still have a variable, you know right away it's going to be one solution. So it's a little bit of a shortcut. They're asking if this is an identity. Now, keep in mind, an identity is always when there are infinitely many solutions. So again, with infinitely many solutions, that means that our variables would cancel out and we're left with a true statement like 0 equals 0 or 3 equals 3. In this next problem, you'll notice we have -5j on the left and -9j on the right. So if we go to add variables to both sides, they're not going to cancel out. We need to make sure that the variables are exactly the same on the left and the right in order for it to be infinitely many solutions. So right away, I know without doing any work that this is not an identity, that this is going to give me one specific answer. In this problem, you'll notice, okay, we have the same variable on both sides. So that's going to cancel out. That means that this -10d over here and the -10d would cancel out when we go to add to both sides. So we're left with a 1 on the left side, and if there's nothing on the right, we'll use the number 0 to represent that. 1 does not equal 0, which means that there will be no solution. In this problem, it asks if it's an identity, which means that we must have an infinite number of solutions. When I look at my variables, I notice that the 4m's would cancel out because they're exactly the same. So if I went to subtract 4m on both sides, they would cancel out, it would disappear. So I need to look at my numbers to see if this would be an infinite number of solutions or infinitely many, or if it would be no solution. And on the left side, -4 plus 6 would be a +2. And on the right side, it's just 6. 2 does not equal 6, so this is not an identity because there is no solution. Next, how many solutions does it have? Well, notice that our variable is exactly the same, -17f, -17f. So we know that they would cancel out. Looking at the numbers remaining, I have 11 equals 11, which is a true statement, which means I have infinitely many solutions. Is it an identity? Meaning, will we have infinitely many solutions? On the left side, when I simplify this, I get -9p because -12 plus 3 is -9. And on the right side, I have -9p. So because it's exactly the same on the left and on the right, yes, this is an identity. It's infinitely many solutions. How many solutions does this have? Well, looking at the left side, I'm going to simplify it as much as I can. So I have -8z, which is going to stay exactly the same, but the -17 and the -16 would become -33. But looking at my variables, they're not the same. So right away, I actually don't even have to. I started doing work I didn't need to do because they don't care about what the solution is. They just want to know how many there are. Since my variables are different, we know right away it's going to be one solution. Silly me doing more work than I have to. Is this an identity? Does it look exactly the same on the left and the right? Well, your variables look exactly the same, 13.8, 13.8f. Perfect. Those are the same. It leaves us with numbers that are different. 16.21 is not the same as -15.4. That means that there is no solution, which means no, this is not an identity. How many solutions? Well, right away, I notice my variables are the same, so they would cancel out, and I'm left with -2.52 on the left and just a 0 on the right. Because that is not the same, that means that there is no solution. Next, how many solutions does this equation have? I'm going to look at my S's. So I see 13.4s on the right, which means I need 13.4s on the left. I have 12.8 and I'm subtracting 0.4. Right away, I know that my S's will not be the same because the one on the right is bigger. So I would need to add to my 12.8, but because it's a -0.4, I'm subtracting. So my S's will be different, which means my variables are not the same. There will be one solution. Next, is this an identity? Will this have infinitely many solutions? Well, my variable is exactly the same, so that's a step in the right direction, but then I need my left and my right to be exactly the same. Because there's nothing left on my left side, it would be 0 equals 18.13, which is not true. That would mean that there's no solution, so it is not an identity. Oh, here comes the challenge. Is it an identity? Do you see the exact same thing on the left and on the right? Well, this is a -18.9v, -18.9v. So that works. Now check my numbers. -1.81 is equal to -1.81. That works. It's exactly the same, which will mean that there's infinitely many solutions. So my answer is yes, this is an identity. Next, how many solutions? Well, I've got a little bit of work to do. I'm going to go ahead and distribute that. So -3 times 3 is -9, and the b just hangs out. -3 times +2 is -6. So that's my left side. On my right side, I have -9b minus 6. It's exactly the same. Because it's exactly the same, infinitely many solutions will be your answer. Is this an identity? Again, what I'm going to do is just simplify both sides. On the left-hand side, -5 times 4 is -20, and the c. -5 times 10 is -50. On the right-hand side, 5 times -8 is -40 with a c. 5 times -10 is -50. And then we still have that plus 20c at the end. And then I've got to simplify this. So the left side is fine. We still just have negative 20c minus 50. But on the right-hand side, I'm going to combine my c's. Negative 40 plus 20 is negative 20c. The negative 50 stays. These are exactly the same. So it means infinitely many solutions, which means yes, this is an identity. We're going to do the same thing. We'll distribute. Negative 6 times 6 is negative 36. We've got the g at the bottom or next to it. Negative 6 times 6, again, is negative 36. On the right-hand side, negative 3 times 12 is negative 36. Negative 3 times 12g is negative 36g. Let's look at our variables. Negative 36g, negative 36g, that works. Those match. Negative 36, negative 36, those match. That means that they're identical, infinitely many solutions. We can also call this an identity. And on the left side of this equation, there's nothing to do. It just says 12k, but we can simplify the right. 4 times 3k is 12k. 4 times 2 is 8. Our variables are the same. However, on the left side, we're left with 0 equals 8, which is not true. This would mean no solution, which is not an identity. In order to be an identity, it would have to be infinitely many solutions. We're all set. On to the next skill.